Hi, everybody. Is this thing working? Yep. Okay. All right. So, I'm just going to get some stuff set up here for a second. But like I said, my name is Tyler David. I've been wood turning for probably like 15 years, I think. I started when I was 8 or 9 years old. So it's been quite a journey. It kind of, I started just because my dad is a full-time woodworker, and I was just kind of messing around in his shop and looking for something to do, and he told me to use a lathe because it was smaller spindle turning is kind of safe. I mean, safer than a table saw, I would say. So I started just making like pillar spindles with different random shapes, and my first product I ever made was a candle holder. So I still actually make candle holders. That's one of my main things still. I numbered those on the bottom, so I keep track, and I'm at almost 10,000 of them made now, so quite a few. And just in like the last 3 or 4 years, I've become full-time. I graduated college, so now I'm making more like lamps and pepper grinders, like I have this one here. Like I said, I make a few different sizes of those. So lamps, pepper grinders, some different sizes of bowls I make too, then like ornaments and some other smaller things. All my items are functional, so they have some sort of function. I just find usually it's easier for me to sell that way if it has a function. So yeah, and my style is kind of, like I said, the color on the wood is kind of what sets it apart. And each piece having a different shape and makes them original, kind of because they have their own sets of shapes and colors. So tonight, this is a cherry piece of wood. My dad and I, we have our own sawmill and 20 acres of land, so that's where we get all of our wood from. This particular piece, it's just air dried. It's been dried probably 4 or 5 years in our shed, and then I bring it into my shop, which is heated obviously, so it kind of acclimates to like a warmer environment for 3 or 4 months or so. And it's probably around like 10% moisture, especially with these pepper mills. I want them to be pretty dry so it can, especially with the mechanism inside, if anything moves and warps, it's going to bind up and not work super properly. So a little bit about like this mechanism that I'm using tonight. There's a bunch of different other mechanisms that you can do for pepper mills. There's crush grind, there's deluxe mechanisms that's sold at like Craft Supplies and Packard Woodworks, and then there's other like less expensive brands too. So each of those mechanisms require different like diameters that you need to drill and different sizing for the piece. So because of that, I'm not going to super like focus a bunch on the sizing, but I'll mention it. I'm going to focus more on like the techniques and the tool cuts I'm doing. So I'm going to take this apart. You can, with this particular mechanism, you can adjust the grind by tightening the top more. Gives it more of like a fine grind, making it, bringing the grinder up closer so it's finer. And you can also make it more coarse by loosening the top. So taking that top piece off, there's 2 parts to the pepper mill. This is the mill body, what I'll refer to when I'm making it, and then this is the mill head. And like you were talking about earlier, it's like rules of thirds. This is 1/3 of the piece, and this is about 2/3. That's generally the sizing that I use. This piece right here, I'll refer to as the spigot. That inner diameter is 1 1/16, and that fits into the hole like that. And you don't want that super tight. You want to allow for some movement in the wood. So you want to have a little bit of play, like a 32nd to a 16th inch of play. And then there's also this metal piece right here. This is like the driver cap. All these parts are stainless steel, so this mechanism is really good. Has anyone ever made a pepper mill before? A few people? Like, okay, good. So you'll know what I'm talking about. And that piece I recess into the spigot, and that's in order to get it centered perfectly. I'm going to focus a lot on like how to properly drill on the lathe. It's really important to get all these holes perfectly centered, and just making everything line up perfectly to make your pepper mill work as good as it can. All right, so now I think I'm ready to get started turning. I apologize I didn't turn this around first, so I'm going to make a little bit more of a mess than I need to, but that's okay. All right.
Everybody likes chips.
Yeah, I guess so. So I've just kind of learned how to center things on the lathe without having to mark it, but as I'm a production turner, so just trying to save time any way I can is to my benefit. So the faster I can turn, the more efficient I am. And this is so this is going to be a 10-inch long pepper mill from the bottom to the very top before the knob. That's 10 inches long. And so I start my blank at 10 inches, 10 and 5/8 inch long. And the extra 5/8 allows me to, it's just like the right dimensions for me, the way I make them, to accommodate the wood I'm going to be taking out from like the center hole in the middle. And then also I slice off some end grain that reduces the amount of wood I have too. Okay. And it's also 3 by 3 wide. Final diameter max on this one is about like 2 3/8, 2.5. So I have some room to give when I'm turning it down. Okay, so I have it between centers now. I'm using, this is a steb center, and then I use my live center as just a cone center. Those two, that's what has worked best for me. All right. There's a couple ways to get this blank round. That's my first step. I prefer to use just a spindle roughing gouge, which is the most efficient way. Recently I've been doing a lot of skew work, so kind of forcing myself to use the skew to rough out blanks I normally do. That tends to give more splintered wood, so I'm not going to do that in this situation. But if you're trying to learn the skew, just forcing yourself to use it as most as possible is going to help you with that. Okay, so using a spindle roughing gouge, I'm like slightly below center. I like to start on the side, going into open air, rather than doing all of it at once. I like to go from the middle out and then the other side out. And I'm like 1,000 RPMs right now. All right, so this is not anywhere near a finished cut. It doesn't even matter if I have some slight flat areas, just it's a rough round piece at this point. So the next step I'm going to be doing is taking my parting tool. I use this is a 1/4 inch wide parting tool. And I'm going to be making that spigot that I was talking about. This piece on the mill head. I'm going to bring that down to a rough diameter, not a finished diameter. That's my first step here. So when I'm making this cut, that spigot is 1/2 inch wide. So that's 2 widths of my parting tool. I don't really use any like measurements just because I've done so many of these. But if you're making one of your first ones, you're going to want to make sure to use calipers and measure everything out. Because if you make mistakes with this, you're going to have to make it a smaller mill or make adjustments. So my mill body is the part that is facing towards the headstock, and my mill head is going to be the part that's towards the tailstock. So I'm going to roughly look at like I'm going to roughly point out 2/3. So this is about 2/3 down here and another 1/3 up here. I'm going to put 2 widths of my parting tool and bring it down roughly to like 2 inches diameter, 1.5 inches. So when I'm making that cut, it's kind of like a peeling cut. I'm lifting the back of the tool handle up as I'm bringing it in. And I'm focusing on the shoulders, making sure they're exactly 90 degrees, and that the bottom opening is the same width as the top opening. Okay, so that's my roughed out spigot. Next, I have to make 4 tenons to hold this piece of wood on the lathe, on the very top, the very bottom, and then both ends of the mill head and mill body. So 4 separate tenons. When I'm making these tenons, I make them about the width of my parting tool. And I only go in like 1/4 or 3/8 of an inch. And when I'm making them, when you use a parting tool, you're going to get a lot of torn out wood on this corner. And I'm going to try to kind of get that edge as clean as possible. I'm sure a lot of you know that when you're putting a tenon like that on the chuck, you want it to be as true as possible and run just as correctly as it can. So, focusing on that inner corner being very clean. And this is the bottom, so I kind of want to pay attention to that. My tenons are included in my final length, and this piece will be turned down, so this tenon is included. Some people, when they make their pepper mills, they cut that tenon off and they do different sizing. So I want to leave this as much diameter as I can get away with, because that is going to be the final diameter of the bottom of my piece. Okay, so I've got those tenons cut out. Next step is to part it in half. You can use a bandsaw for this. I use a narrow parting tool. This is a 1/16 of an inch. And I'm going to part it right here at the base of my spigot, closer to the tailstock. I want to save as much width of my spigot as possible. So same with this cut. It's kind of a peeling cut, arcing up, and I'm stepping it down. I'm not doing it all in one pass. I'm starting here, going down 1/2 of an inch or so, come back up and step it down. Okay, so now I've got it like 1/2 of an inch diameter. I have to be a little more careful. If you want to push all the way through, it'll pinch, and that's when you can get a catch and this thing can fly off the lathe. Okay, so right now it's like 3/8 of an inch. I'm good with that. I can go ahead and take this off the lathe, and I can just simply twist this and break it. Now I have my mill body and my mill head. So next step is going to be to do some boring on the lathe. And I'm going to go ahead and take out my drive center and switch that out for a chuck. Yeah, I brought everything I really need. So, usually I was using a smaller chuck. I use one-way chucks. I just bought this chuck actually. I was using a Talon chuck, if anyone has one of those, but I just bought a new one. Works better because it's larger. Okay. I'm going to go ahead and remove my live center here. And this is a drill chuck with a carbide bit, and the diameter of this is 1 5/8, my first hole.
What brand bits do you use?
I don't know. They're made in China. I buy them on Amazon. I would not recommend to buy or to use high-speed steel or carbides. Or this is carbide. I would highly recommend using carbide when you're boring anything out on the lathe. So I'm going to put this on here with the bottom exposed, the piece that was in my head or drive center before. So when I'm putting this on here, I'm going to try to get it to run as true as possible. I give it a few rotations to kind of clean off any excess fuzzy wood that's on there. And that's running pretty true. It's off probably like barely any, but that's fine. Okay. So drilling on the lathe. Actually, first, I missed a step. I'm going to have to, first thing I do is true up this surface. There's a couple ways to do that. I'm going to show both ways. I like to use a skew or a spindle gouge. You can do that as well. So I'm going to start with the skew to see how that goes. So using the long point of the skew, that's the point that fits or goes up higher. I'm going to make, I call this like an end grain facing cut. I'm arcing it, the back of the handle up as I'm going down. I start with a little chamfer right there that kind of gives me like a bevel to start my cut at. I'm going to turn my speed up a little bit. I'm around like 1500, 1400. So once I get that cut started, with this cut you're taking a very minimal amount of wood off. So I'm just getting it started. And I'm starting with just this point, just the very point of it cutting. And as it's more established, I'm more so shearing it with, or cutting it with the bottom 2/3 of the skew. And the skew does a very good job at minimizing your sanding if you're cutting it right. So that's why I like using the skew on an end grain facing cut. Also when I'm doing that, I'm trying to get it slightly undercut because this is going to be the bottom of the pepper mill. That's how it's going to sit. And like you guys were saying before, you want a nice undercut surface that it sits on so it doesn't rock. So I'm going to go one more pass just to make sure that it's undercut. And I'm taking barely any wood off. I'm going to just put a little pilot hole right there for my carbide bit to start that has the same kind of size pilot hole. I'm going to back up my banjo here. And a lot of people like to drill very slowly. I like to be around 800 to 900 RPMs for this size of a bit. And when I'm doing this, I bring the tailstock up so it's not touching. It's about like 1/8 of an inch away, and I take my left hand and I support the Jacobs chuck or the drill chuck and put kind of backwards pressure into the quill. That's kind of centering it, and I very slowly bring up the bit, revolving the tailstock, and let it kind of find its own center. You don't want to fastly go into this. If you go slow, the center point of that bit finds its center. The wings come up and touch, and the wings find their own center as well. So I'm starting very slow once the cut is established. And you can see there's very little wobble. I can go ahead and cut fairly fast now. And this cut is going to be about that deep. I don't know the exact dimension. I just always know that I go to the back of my carbide bit right here. If you can see where I'm pointing, it's roughly like 3/8 to 1/2 of an inch deep. Okay, so now I'm going to go ahead and change chucks. Since I make so many of these, I just have 2 drill chucks, so I can always keep a different bit in one. I don't have to switch them out. So my next one is a 1 1/16. Again, it's a carbide bit. And with this bit, I'm going to drill halfway through on this end and then flip it around and drill the other halfway through. Some people use a drill bit extension to go all the way through, but you're not going to come out the other end exactly centered. So you want to do both ends and meet in the middle. And I should be able to have enough length here to, sometimes I have to adjust the shank on here and extend it out so I have enough length. So with a smaller diameter, I can afford to turn up my speed slightly. I'm at like 900 to 1,000 right now. Same thing, I'm starting very slow with pressure backwards into the quill. Now it's established. I don't have any wobble, so that's great. And I can just go ahead and crank this thing home. Some people use an air hose to get rid of the chips as you're drilling. That'll help you, especially if you're using a high-speed seal, that'll help. So that's about as max I want to go on one pass. I'm going to go ahead and back this out.
How many times, I know it would vary on the types of wood,
Yep.
but how many times how long do those last?
Yeah, it's kind of crazy. I've made like probably 400 or 500 of these, and these are the second bits I've bought. So
Really?
they last, yeah. So I'm just gonna max this out as far as I can go before my chuck bottoms out. So that's all I've got. At home I have a Laguna lathe. I like it. I like this one almost more. The only thing I don't like about this for making pepper mills is that it takes a lot more revolutions. Mine extends the quill 1/4 inch every revolution. This one is like less. It might be a 1/16 or something like that. So I'm going to take this out now, and my next step is going to be to clean up this surface inside here and the outside. This is the last time I'll be able to access this when it's spinning on the lathe, so I want to clean this up now. Is it okay if I do a little sanding in here, just like barely any, 20 seconds?
It's too much, we got a vacuum.
Okay, yeah. It shouldn't give a whole bunch of dust. Okay, so now without turning the lathe on, never shove your finger in here when the lathe is on. But I'm just gonna, I've done it a couple times, but it's not gonna end good. So I'm just gonna try to remove, this is where you would on an air hose and get rid of that dust, but this will be fine. And I'm gonna position my tool rest over here. Okay. It should be good. I think it'll be fine. I don't use one at home, so I'll be all right. So my next step is to find my parting tool, which is right in front of me. So this is kind of a weird cut. This inside edge, yeah, you can see it good on that screen. Here, the carbide bit obviously doesn't leave a very clean surface. So what I'm going to do is come in here with the very corner tip of my parting tool. You can use a skew for this too, but this works a little better. You're going to want your tool rest pretty low. And some people call this negative rake scraping. I want a pretty high speed, 1500 or so right now. And I'm just going to ever so slightly, when you're doing this cut, it's crucial to be very stable and go in very slowly. So I'm just grabbing the corner of that. Getting rid of the sawdust, and I bottom out and I continue, but I'm looking for ribbons of shavings. As you can see, they come off nice and clean. I try to minimize the vibration by stabilizing with my forearm here. Make sure I cover the whole bottom. So I'm scraping end grain there with the parting tool, and let's see how that surface looks. Okay, so I didn't do a very good job on the inside, but the bottom looks nice and clean. I'm going to go ahead and try a little more on the inside surface with a higher speed. Okay, so that still has some tear out. That's where sandpaper comes in. And that is also, it's crucial to get this clean, but that's not the outside of the pepper mill. That's going to be seen somewhat, but not a bunch. Okay, so I finished the bottom with 150. And then I use the sandpaper kind of to make a little bevel on this inside edge. I go on the inside edge here, but I don't shove my finger on the inside, the very inside. Okay, then I have a dowel with a slit cut in the inside, and this is 80 grit. I'm going to go ahead and sand the inside, getting rid of like all the fuzzy wood that's left with the carbide bit. Just because when someone goes to fill this pepper mill, that's where the peppercorn is, on the inside there. and you want them to not like see wood. They don't want wood mixed with their peppercorn. So, so I kind of am going back and forth to extract the sawdust at the same time as sand. Okay, so that should be good. It's hard to tell sometimes, that's why the air hose is nice, but you can tell by feel usually. So now I'm going to go ahead and rotate this on the lathe. So you can kind of see what I've got going here now. Put this on here so the other side is exposed.
Hey, Tyler.
Yeah.
You said that you won't be touching that other end,
Yep.
but your jaws have those lines, so if you tighten, you'll get the lines.
Yeah, you're definitely marring it right now. But I'm going to finish the entire exterior with those exposed at a later time using a jam chuck. So I mount this
Okay.
piece in my chuck, and this, you can kind of see the ring on this. This goes inside the interior hole, and so then you can access that piece that's marred,
Okay.
and you can clean it up.
Good question, Alex.
Yeah, good question. All right, so repeat those steps over again. I'm going to go ahead and clean this end grain face up with my spindle gouge now, just to show you there's different ways to do it. Same kind of theory. You're starting your cut bevel, rotating my flute kind of down, bringing the back of the tool up as I'm cutting, and I'm shearing down. It's not necessarily crucial on the inside 1/16 because you're drilling that out anyways, but the outside area is more so crucial. And this is also undercut. Okay. So that is clean enough.
And is that undercut so that you get a better fit from the top?
Yeah. So this is what this surface is right now. And as you can see, when I'm done, not much of it is left. I have an undercut here and an undercut here. That's just so these kind of don't have like vibration or squeaking action when you're turning it. You want a nice, the edge of the surfaces to touch each other. All right, so I don't have to drill the 1 5/8 diameter hole here. I just do the 1 1/16. Turn my lathe to about 1,000. Bring it up close, lock the tailstock, slowly start again. Sometimes I forget and I just am in production mode and I crank it too fast and then it starts to wobble. And then I have to go back and try to fix it. See, there's some slight wobble, if you could notice that. And I kind of halted. What I'm going to do then is just focus on going very slow so it fixes itself. And it kind of alleviated that wobble. Now it's established, I'm just focusing on putting backwards pressure into the quill so it stays where it is. And you can feel it relieve pressure when it's all the way through. All right, so a little bit of sanding now. This is 150, but it's worn out 150. I know that it doesn't change like the pattern of the sandpaper, but it definitely acts a little different than fresh 150. So it's going to give me a little more of a polished sand than a fresh 150 would. So getting rid of that sandpaper, sometimes you have to break through the clump of dust that's in the middle. So making sure I'm getting past the center point where they connected. And sometimes there can be a slight overlap where your bit met each other. So you want to focus on sanding the middle as much as you are the outside.
That's an inch and a 16th.
Yep, that hole is 1 inch and a 16th. Okay, so looking at this surface, no tear out, so that's good. If there's any tear out, I would go back and try to recut it at that point. And that, as you can see, I was removing wood from this surface and this surface, so that's also where my 10 and 5/8 inch length at the beginning comes into play. I'm taking some off there, and then that inner hole, that first hole I recessed, that's some that I took off as well. All right, so I'm going to go ahead and take this piece off the lathe. We're now done drilling the mill body, and we need to drill the mill head. So I'm going to put this on here first with my roughed out spigot pointed out so I can access that first. Okay, make sure it's running true, looks pretty good. And my first step here is to get this spigot roughed down to the shape or the size right here, 1 1/16 diameter. I'm going to go ahead and use a peel and cut with the skew. Be careful not to go too far. So I get it roughed close. Make sure you shut the lathe off before you check the fit. Otherwise it'll grab it and it's not good. So it's like 1/4 inch too big right now. I'm going to forget about that for a second. I'm going to go ahead and clean up this surface. You can see all the tear out there from my parting tool. I'm going to use that same method I did with the skew, long point down, shearing end grain cut, chamfer, slightly undercut here too. Okay, that looks pretty good. Now I'm going to switch to a planing cut with the skew. I'm starting with the short point here, and I'm using this because it gives me a clean surface rather than peeling with the skew to remove the last little bit of my spigot to make it fit my hole there. So grab your cut, starting it out with the skew, slowly bringing it in, and then turn it off, check my fit. Okay, so I'm barely can fit right now. And like I said before, I want it to have a little play. I want it to have like a 1/16 of an inch of play. So I'm going to be careful and not take too much off. See how that looks? Still too tight. Check if I have any tear out. I'm not too worried about tear out like on the outside here. I want to check more on towards the spigot because I know this is going to get removed, such as this one did, because I like to get a smaller area where they connect in the next steps. So I have a little bit more to remove. Bring out my tool rest a little closer. That should be good now. Okay, so it has very little play, but I'm going to call that good for a demonstration. Okay, so next I have to cut a recess for that driver cap in the end of this spigot. I do that because I want that perfectly centered. That's hard to screw it on. If you just left this flat and you tried to screw that piece on there, it would be hard to get it centered with the hole I'm going to drill eventually here. So this is kind of like that end grain scraping method I used the parting tool for. It's hard to use a skew for this because it's not the right shape. I use a little radius on my skew. If you had a smaller skew, you could do that. So the tool rest is pretty low here to accommodate my, the width, the height of my parting tool. For speed, I just look at the outer ring for my diameter. I just know how much is supposed to be left there. And it's about 1/8 of an inch, possibly, something like that. And it's only, I'm going in only like 1/8 of an inch as well. It doesn't even recess that much. All right. So that's all done. I'm going to give this a little bit of sanding on this surface. This surface. I don't really want to sand the outside of my tenon because that's going to change the diameter. I'm going to switch over to this twist drill bit. This is a 9/32 inch here. And that is the hole that goes through the whole mill head that accommodates for this shaft that comes up through the top and has a threaded piece on it that the knob connects everything with. Any questions right now?
I got one. When you're
Yeah.
doing your facing with the skew,
Yep.
you start with that little chamfer. How does that help you?
It just gives me an angle to cut at. If I started right here, it would be hard to pick it up. It's about picking up the cut, I would say. Just gives me a better access point. Okay, so same dynamics with this bit. You're starting slow. This also has a pilot hole, so that finds it centered. This one, believe it or not, is more crucial to get centered than the other ones. Okay, so when I get this one established, I release the tailstock and then just go ahead and push it halfway through. And that's why I also have this secondary tenon here, because I have to flip it around and drill halfway through the other end. Like I said before, if you drilled all the way through with this bit, it would likely come out off-centered on the other side.
So all these sizes of your drill bits and stuff
Uh-huh.
could vary depending on the
On the
type
kit.
of pepper mill you're
Yeah.
making.
Yeah, that's why I kind of said, like, I'm not going to focus so much on the different sizes, but the technique.
That's why you stick to the same hardware.
Yeah, I use the
You've got
same kit
everything
every
there
time.
that You can just buzz through. And
Right, yep. Yep, different kits require different parts. But as long as you know the fundamentals of boring out and facing end grain, you can do this. Every kit is going to be somewhat similar. So this is the top of the pepper mill. I don't need to face that up, because usually what I do is I round it over, so I'd be kind of wasting my time if I cleaned it up right now. And that already has a pilot hole there from my live center before. All right. So you can kind of tell when the lathe is on if you're centered there. Just by looking at the hole, you'll easily be able to see if it's wobbling. If it's even off like a 16th, you'll notice it. All right, so now we're going to kind of switch gears and do the outside of the pepper mill. We're now done completely with the inside parts of the pepper mill. We have a sanded bottom, and we have a sanded end grain surface here where our tenon is, or our spigot, and the top of the mill body. So everything on the inside at this point is done. So now what I want to do is mount this thing on the lathe and be able to turn all surfaces of it besides the bottom, because the bottom is done. So I need to find a way to get this snug fit in there, otherwise it'll be spinning. And as you can hear, there's chatter right now because there's too much surface, which is another reason why I bring that area down. And I also put wax on this surface. Another common question is, what do you finish the inside with? I use liquid beeswax. There's a lot of different theories on what you should use. Some people say, like, you don't use oil because it never gets rid of the smell. Some people say don't use some things because they're not food safe, but every finish, I think, is food safe once it's cured enough. So really you can You can use anything on the inside, whatever you're comfortable with. You could brush 10 coats of polyurethane in there if you wanted to, and make it really smooth and shiny, but being a production turner, I just want something fast and what I can get away with. Okay, so this is basswood. This is really soft wood. I've used hardwoods like cherry or maple for my jam chucks before, but they cause like some squeaking. I also, when I'm making this, it's just a scrap piece of wood that I taper down, and I want the end of it to be smaller than my 1 1/16 hole here so that it fits inside that hole. I don't want it to be like riding on the inside here so it has an area to spin. I've just found that is the best hold if I do that sort of thing. And then how do I get this to be snug in here? There's a few different methods, but I use a paper towel. Sometimes you're gonna need 1 layer, 2 layers of paper towel. I'm just gonna try 2 here. I'm gonna shove it on here with 2 layers of paper towel. And I'm gonna take it out, and then I have it marked, kind of. I take my scissors, and I'm gonna cut like a 1/4 inch around where my mark is. And I want it somewhat even. I don't need this to be perfect, but if you had more paper on one side than you did the other, it would slightly cause it to be off. So I'm just gonna cut this. Feel free to throw a question at me anytime if you have one.
On your typical day of turning, do you vary between the things you're making?
Yeah, definitely. I mean, sometimes I'll punish myself and do 15 peppermills in a day, but I like to definitely change it up. And I could do like all this part in one day and just do a bunch of these and then set them aside, do them later. But I like to start with a chunk of wood and make it finished. It's more fun that way. Trying to make it not a production line as possible. So that's nice and tight in there now. Once I put this in here, between centers, I'm going to use my cone center on this side. And this cone center, that's kind of why you don't want to use, it doesn't work really well to use a live center like this, or this is a dead center, but they have live, my lathe came with a live center that rotates like this. I'm sure you've seen those before. But if you use that, you wouldn't be getting it centered in that hole. So using a cone center, some people are afraid that that's going to make it split. You just kind of have to be conscious that you're not tightening it, over tightening it. And when you get that diameter down further, you don't want it to be super tight. Just because then it does have a tendency it could split. So make sure my tailstock is locked. Bring it up, tighten it. Watch my segment here to make sure those two line up and that there's no gap in between.
And obviously you're not worried about the tail, the cone center.
Widening it out.
Widen it out because you're going to turn that you're going to turn that down to a round part, so part of that's going to come off of there anyway.
Actually,
right?
no, this is part of it, and I might have just made it too big, but it usually is fine. This is the finished width or length, so that is part of it. We'll expand it a little, but like I said, make sure you're not tightening it too much. And I'm looking at this now that there is a slight gap here, and there's not as much here, so I'm going to revert back to one width of paper instead of 2, because that might have been too tight.
You line your grain up so like it's just one piece?
Not really. I don't pay too much attention to that because it's going to be always spinning. The grain orientation matters, but not too much because you're always spinning this and it's always going to be in a different spot. Okay, so I'm just going to change to 1 instead of 2 layers. And now is the fun part when I get to make the shape on the outside. I have a little more creativity. And as you can see from my shape here, I kind of explained it before. I do a different shape every time, but I have a few parameters that I follow. I want a nice rounded top that fits in the hand well. Okay, so that's fitting better now. And then I want a nice rounded top, and then kind of a nice elegant flowing for your bottom hand to feel the mill body. Okay, get that nice and snug. One thing to watch, since I made both of the cuts undercut here, as I turn this down, the piece is going to lose pressure as I turn that area down. So I'm going to have to continue to tighten up my tailstock. Okay, so I'm going to start with the skew here to get a rough shape using some peeling cuts. So when I'm using the skew, I want this slightly above center. And I'm just going to get it down to a rough shape. Starting out over here. Getting it down to my final diameter, I want the bottom to be the largest diameter part of the whole thing, just to kind of make it so it's more stable at the bottom. Okay, so I lost some pressure there as I was bringing this area down, like I said, so I'm going to make sure this is more snug. So I've got a decent rough shape here with a kind of a nice area for my bottom hand and then the top as well. It still needs quite a bit removed, but I'm going to kind of change angles here and now go into more detail. I kind of just go off the cuff with the skew usually, and then if I need a more redefined cove areas, I'll switch to my spindle gouge and do coves rather than shearing cuts and beads with the skew. So I'm going to start at the top up here, and I'm kind of trying to make a large bead. I'm going to try to somewhat do the same shape as what I've got there. So here we go. Shearing with, planing with the skew, making details. I'm always starting with the short point, or not always, but when I'm making more gradual cuts, I'm starting with the short point. Using the bottom 2/3 of the skew. Roughing it out. It is helpful sometimes if you want to draw a line in the center to kind of remind you where the center starts. If you're concerned about your top diameter here, you're not going to want to start in the middle. You're going to want to start more so on the sides and work your down. Otherwise, you're diminishing your final diameter there. This is kind of where I would switch to starting with the long point. Kind of a good rule of thumb when you're taking steeper slope cuts with the skew, I like to switch over to the long point. Okay, so I'm remembering where that seam is. Usually it's hard to see, but I can see it pretty well here. And with that seam, I like to kind of camouflage it and blend it into like a shoulder or a point. And that's kind of difficult to make sure you're getting exactly right where the point is, where the seam is. You also have to be careful on your diameter here. I can't go lower than 1 1/16. I want to keep it actually around like 1.5 inches minimum right there. Okay, so I'm kind of just looking at this now, thinking where the shape is going. And I don't really like how big this is. I'm going to take it down. Turn my speed up a little. So when you're making beads with a skew, it's hard to get them like perfect like this, but I start with 150 usually, and you can, using good techniques with sandpaper, you can redefine the shapes of your piece. You can also hurt the shapes of your piece by getting rid of detail, but using the right techniques, like you can form a bead to make it look more elegant and just overall better using your sandpaper. Another good thing the skew is good for is that it's so narrow. I can get nice depth and kind of a shadow effect by going deep into a V groove here. I don't have to worry about my diameter on the top staying like an inch away from the connection, but I can get a little bit more definition by going deeper above that connection. Okay. Yeah, it's barely above center. That's kind of personal preference a little bit, but I feel it helps me if it's above center using the skew. Using the spindle gouge, I do slightly below center. I'm going to try to make this a nice spherical bead right here with another accent bead right below it. Okay, being careful with my seam here. That's about as far down as I should take it.
And Tyler, were you about 2,500, or what
Yeah,
was
it
the
was
speed?
probably like 2,000 RPMs
2,000.
there. Yeah.
Okay.
So I usually start with the top, and I'm going to go ahead and call that good. You can look at these beads. They have tool marks, and they're not perfect, but like I was saying, you can fix them a lot with sandpaper. I'm actually going to try to do a little bit more depth right here and then move over to my mill body. Being wary of how far my tool rest is from the piece. Using the skew, you don't want it to get too far away. Just doing a little shadowing depth right here. Okay, now I'm happy with that. Usually when you're happy with it, you go back and try to change one little thing and you get a catch and destroy the whole thing. Okay, so I'm gonna work on this section. This is a little too fat still for my liking. I'm gonna bring it down. Okay, so just nice elegant sweep here. Not as much detail as the head. And when you watch this on the video, I've watched a lot of videos of people using the skew. With the tool rest being higher, it almost looks like the skew is on top of the wood. it necessarily isn't, but it is very beneficial to be higher up using a skew and a planing cut like that. So I like to do a little detail at the bottom usually. At the very bottom, I don't want it to be a complete 90. I want a little round over so that when it sits on a table, it's kind of lifted up, it looks like. Okay, I'm going to switch to my spindle gouge here and lower the tool rest. I want to do a little bit of a cove detail here. Exciting. Careful of my diameter. Okay, now I'm going to switch back to the skew.
And was that about a 45-40 grind on that?
I honestly don't know. I just grind it to my preference. I change it a lot.
Okay.
What I'm doing. I know there's a lot of like info out there about like 40-40 bowl gouge grinds. It's important to pay attention to that, but you can also figure out your own stuff pretty easily too. Or not easily, but just through trial and error. There's my first catch. Oops. No, had a lot of. I knew I would do at least a few mistakes. No, I've made a lot of catches with the skew. Okay, so like I said, I'm using a long point here to kind of create more definition. Just gonna work on rounding the top of this bead better. Okay, now I'm gonna make this sweep a little bit more rather than just flat like it is. Okay, now I'm going to do one final finish cut, try to make it smoother. Okay. So I like to look it over pretty thoroughly before I start sanding, just so I don't find mistakes later on. But I definitely have a little tear out from the spindle gouge doing this cove that I did
So
here.
since that's cherry, are you still gonna stain it?
Yeah,
with
yeah,
the-
I would definitely color
Okay.
this as a finish. And then this is finished with CA glue, but I've been kind of messing around with that lately. A lot of people like when they're finishing with CA glue, which I think it works better, but when you put it on the paper towel first and then wipe it, I've been kind of experimenting with holding a paper towel and the bottle at the same time and slowly dragging it along, but applying a lot thicker of a coat at once. Yeah, I do use medium when I'm doing that, like a thick coat, pushing it out at the bottle and wiping it kind of behind, turning like pretty slow, like 300 RPMs when I'm doing that, but that's really, and then I go over that, I spray applicator on my paper towel and then go over that after that. And I have definitely not perfected that yet, but working on that, so. I'm not gonna sand this or anything, but this is done turning now, and I would move on to sanding. I just start with 150 and then end at 150, so.
What's the
Um,
favorite mechanism?
The deluxe mill kit you can buy it from Packard Woodworks or Craft Supplies. I don't know if Penn State sells it, but
The deluxe is like a.
deluxe. Yeah, I think so. It's just higher quality part. It's made in the USA. It's made in Pennsylvania by Chef Specialties. It's a pretty good one. Any other questions?
You were saying, when I was talking to you earlier, that the salt grinder, you can't use that same,
Yeah.
you have to use a porcelain because the salt will
Right, yep. This has all stainless steel parts. Salt is corrosive, so that would it would corrode that stainless steel over time. You have to make a different mechanism for it, so. But I've just kind of stuck to making pepper grinders, and then I make salt shakers. I don't want to do two different grinder kits, just for like having to buy a bunch of kits then, but. In a day, I could do like, I don't know, 12 or 15 of these, but that's probably without the finishing. The finishing is kind of finicky for me. I'm still learning that for sure. But
Thank you very much, Tyler.
yeah,
Any
thank you
other
guys.
questions?
I really appreciate it.